That's got to be the best part I've ever seen.
So it would seem.
That's got to be the best part I've ever seen.
So it would seem.
That's got to be the best part I've ever seen.
So it would seem.
Okay, there we go. Alright, so there's the audio delay. Okay, so this is the programming live stream, and so last night I was on this programming groove making this graphical program where you have a robot with omnidirectional wheels, and you want it to both rotate and move at the same time. This was a so the Texas A&M RoboMasters were working on the solution a few months ago, and I guess I want to see what's my spin and how it'll go. So right now I was able to just experiment around and look around how to work with the Python UI stuff. So really, the most significant thing that this has been able to do right now, just make a window. And right here, if we go here into our test code, so this is kind of like the test code I did for just learning the library and whatnot. And all you do is go Control V. Let's remove this, and then we're just gonna go make a, I believe, yeah, there we go. So we still have this. So this one is very arbitrary, so to speak, because all it does is just make this. But hopefully, after like a couple of minutes, we'll be able to get at least something like maybe a picture of the robot. Now, how I'm gonna render the robot is that the robot is, now if I were to just link the robot together and move it, that's kind of like no bueno ish, because it's, the point is for, let's say you have two wheels like this, and let's get a better brush, like this and this, and these wheels, if you are going relative to their median point, they're going to be rotating. If you are relative to the ground, their median point is going to be moving that way. And so we want the wheels to get their vectors in such a way that both of this is happening. The current solution that I'm doing right now is I'm going to generate an orthogonal vector for these wheels, like so, and then I'm just going to add the desired velocity motion to them. And by adding said vectors, we'll have a movement, in theory, that's like that. Trying to graph all this vector stuff, I don't think Desmos is too capable of that, and trying to find another program that'll do that is might take a bit while. So instead, we're just going to make one ourselves. So currently, the problem that I'm trying to figure out is how am I going to connect the robot object to the rendering. So currently, my solution was to make a proxy for the robot, and so here I'm being the robot module. There's something called a robot graphics, or better known as the graphics proxy. So all this does is contain the canvas and whatnot. However, when I do that and call the robot function, it's not it's not rendering anything, as you've seen in the first run. So I'm gonna see if someone has done something like a ball simulation where you have an individual object type, and then they have it linked to the renderer, and see how they do it that way. Because I was trudging through the documentation, but when documentation fails, finding example code is better. So we're gonna see, let's see, Python TK enter ball simulation. Bruh. Okay. So
at making a bouncing ball simulator program. This is something that I
ball
was asked by a student,
TK.
so I thought I would make a quick video out of it. Sorry if I use the.
Okay.
First, I like what.
Oh
I'm
no.
gonna put a little. So I'm gonna all to have a shape.
No. Is
This
this
is about 200. Third.
turtle?
Turtle. It always starts.
Bro.
As
Okay. So this.
Do I out of physics ever
Okay. So there.
break it. So.
Okay. So let's see if we have another one.
Hi and welcome to Python Bounce. Let's see how.
So import time, ball, self init, hit tab, draw, self.canvas, canvas, blah blah blah. Okay, so this one does use TK. So it appears that when someone wants to link something to it, it's gonna have its own canvas and initialize itself. And when it's drawn, canvas will. That's a very interesting way. So the canvas will just move. So instead of drawing onto canvas frame by frame into some sort of frame buffer, which I guess would be more low-level thinking, because I did a lot of low-level stuff during the lockdown, where like it was so low-level I had to program my own keyboard drivers and screen drivers to like even have I had to make my own terminal. It sucked and was both fun. Crazy thing about it is that the keyboard drivers, given the keyboard standard, because there's 3 main keyboard standards, arrow keys did not exist for that one, so I had to map that out. That's actually probably why, like, I'm guessing Vim originated using the JKHL. It's also more convenient as well. So instead of WASD, oh shoot, since that's also reserved, J moves down, K moves up, H of course does left, L moves right. Let's see, so what he did was he stored a canvas. When it draws, the self.canvas.moves like that.
So let me see. What else does the
So pause, move, if pause, blah 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 blah. So this is just drawing. If the pause is this, pause is that. Let's see. So really, if a programmer does not write documentation for their like library or whatnot, or you can't find documentation on or a tutorial, you really just have to like hunt for code that already uses it in order to understand how to do stuff. Trying to derive stuff yourself will like take a lot longer. It is a good like exercise, but I am aiming to solve this project like within the next few days. Let's see.
time on this?
So that's the position. So if position is greater than 0, the self.y is equal to 2. If the position is some sort of list. POS. That's pretty interesting. So self.x, self.y. So he could like do composition of x and y, so it's just in like a single vector. That could also be stored in a vector together, some data structure. Okay. Now, of course, the end of the day, really, well, the end of the day of your first day, you really just want your code to work. But like on the second day, metaphorically speaking, although it could be literal, you know, you want your code to get more organized. You want it to be more refined. You want to optimize it. And and unless you're using macros for coding, which you might come across more in low-level stuff in order to squeeze out performance. Linus, who made Linux, actually was known for having very high code standards and for just optimizing every little bit. He was basically the Gordon Ramsay of programming, and still is. Actually, during a Linux convention, gave NVIDIA the middle finger for not helping out Linux enough, because one of their programmers basically was saying, yeah, I mean, it's fun to make your own NVIDIA drivers, but I kind of don't want to have to do that. I'm actually rendering this on NVIDIA, so NVIDIA did start giving Linux a lot more support. After that, especially, I guess, you know, all press is good press, so to say. Let's see. So, definitely, right now, let's see, get status. So, main.py, so we want to undo all of this. There we go. And we're going to keep it like that. Now, some of you might be wondering, what the hell am I using for programming? This is called tmux. So this allows you to have multiple console sessions into one. This was very useful back in the day when you didn't have a desktop program for the terminal, so you just have a text. Like this would be just what you'd see on the computer screen. You wouldn't even have a mouse. You might have a mouse pad that might be linked to such, but at the end of the day, it's just a screen. So being able to have multiple terminal sessions at once is very powerful. So I have one here for running the stuff, I have one for using Git, and then I have one for actually coding. Vim, it does come with its own like code completion engine, but it's very basic. So I installed YCM. YCM support for C++ and Java is actually very good. Unfortunately, I've noticed that its Python support wasn't too good, so I installed another one called Syntactic, which allows to like it also lints the Python code, so like if I don't format it right, it will like really get onto my ass. For example, in Python, the standards is that between class definitions you want 2 empty lines of space. In C++ and everything else, I've been just doing 1 line of space. It's like small stuff like that. Here, it's also complaining this variable is assigned but never used. Now, since this is tk-enter, being tk-enter, I don't need to use the robot thing. I just need to declare, put it in a variable. So this one's kind of just proxy syntax, so to speak, to achieve said thing. So let's see. So self.canvas equals canvas. So I'm probably going to have a robot, and then I'm going to have a wheel class. So the wheel classes are probably just going to be like 2 circles, 2 circles. And they're going to be basically this, and they're just going to rotate. So if I have 2 circles rotating and translating, and that's going to be good. Eventually, I'll start adding up some vector drawing. So like that's probably easy. You just make some formulas to draw the lines, create some arrows. Actually, a lot of like the pre-made stuff in like PowerPoint, Microsoft Word, this is actually how you program it. For example, you have point A, point B. You basically tell it to generate a lot of this. If you want it to be smoother, you use a certain algorithm to like smoothen pixel stuff by some like random guy created a few years ago. If then at one of the points, if you want an arrow, you tell the program, put arrow at this point, draw lines to here, or draw a triangle. Like it's really a lot of math, and it's honestly getting really creative with math at the end of the day. So like rendering all of this, for example, these gradients are mathematical equations implemented. This is just like telling it to fill, and then zdef, how it would work is that at least how I implemented zdef is that it would draw everything first on the lowest zdef and work its way up. And how that would work is that whenever I added a pixel to a frame buffer or so, each pixel would be sorted out based, like zdef would be sorted out. So the lowest pixels would be rendered first onto the actual like canvas, because I was making a render engine for actually the console, because I was planning to make my own platformer with like console-based physics engine and whatnot. I kind of dumped that project for now for doing best some Python stuff, and not Python stuff, and operating system stuff. That stuff is way cooler. But basically the canvas is the frame that's actually showed onto the screen, the frame buffer just holds more pixel buffer. Frame buffer. The reason I'm saying frame buffer is because that's what computers use in their like low-level graphic stuff. But the pixel buffer holds like a bunch of pixels, and it will render it sequentially. So all the pixels at the start will be the lower pixels, and the next pixels, will be of like the higher z-def. So it will just like by its nature paint over all the lower pixels, and you get your z-def mechanic working nice. So now let's go here. So it says it wants the canvas to do this and that. So what does it do? There should be a loop. So draw if blah blah blah. Like this one, he's not even using a game engine. He's just like he's programming his own physics, which is pretty cool. So ball dot hit bottom equals to false, blah blah blah. Paddle dot draw. So let's see. So I'm trying to find how he adds it to the TK. So canvas equals TK with height thickness, packet TK update. So let's go up here, because in the TK library you have this thing where it's like right here, so root equals tk.tk. so this basically allows you to access like the actual manager itself. So root basically contains all your stuff, and then to link it you instance like some sort of graphical window thing, but then you give it a master. So the root would be the master of this, and so this one is a RoboGraphics being like the root of this, and so on. So I'm trying to find where does it assign a specific master to its like thing, because how I was taught was that you would make a class that inherits from tk.frame, but obviously there is some other way that you could do it without using tk.frame. So canvas.canvas paddle canvas.create oval random shuffle star. So this is a ball. Canvas height self.canvas w info. Oh, that's cool. So this is the definition of a ball, and now we need to find where does it instance the ball. So canvas, there we go. So canvas equals that, but then canvas.move. Okay. So this is like called API documentation. Some of it's good, some of it's bad. This does echo a lot of like 2000, not even 2010, like more like 2009, maybe 1990 vibes. But this is actually 2019, the HTML version. I'm guessing they use something like Doxygen or some older one. The newer one called Read the Docs, it can link itself to Git and automatically generate it, which is a bit more cool. So canvas.move. So you have a canvas widget. So Python stores a variable by reference. So we made a canvas of here. So he makes a canvas, and then canvas.pack. Then we pass the canvas into there. Let's see, where is it? Python. Okay. So canvas.pack. So it created canvas object, blah blah blah. Supported options. Oh, these are the supported options. But then here, these are the create oval. So the methods create objects on the canvas. Canvas coordinates is probably just going to explain, it's like, so in computer graphics, it probably stems from terminals and whatnot, is that the down direction is positive, the up direction is negative. Because if you're doing coordinates for like debugging, you know, here, boom, the numbers are positive. So the deeper you go, the positive it is, and then as you go right, it's like conventional positive. So yeah, this is actually how like how you would actually program learning, like with a new GUI. You basically play around with it, try to find documentation or information of how people have used it before. So we have root, Robographics, yeah, this one, now we got 7 minutes. So even though I didn't really write much code, I've learned something pretty new. Is that, you know, you can store a canvas object in the object. You don't need it to like be proxied by TK frame. So we're actually gonna yeet that. And so git status, git add src robot.py git commit /m, make a robot class. Add git commit idk lol. Now usually for a more serious project, you want your git commits to be something not like that, because if you do git log and you want to try to find where a glitch happened, make a robot class is better than just saying idk lol. Fix stuff is no bueno. You probably would have to like go through the more detailed version showing which lines were changed. But that's that. So git branch /b, and I'm gonna call this robot graphics. Git branch /b robot graphics. Let's see. Git checkout robot. Oh, git checkout /b robot graphics. There we go. So in Python, you want to commit too many times. You can always merge your messy commits using git rebase or something. You can even use git cherry pick to pick like certain time frames and then merge those together as if only those happened. Some people like to contain the entire commit history to show the entire story of development. Some people want a more makes sense, you know, these are what actually matters. There are pros and cons to either one. But yeah, so we have robot, we have this, and then we have that. So we want it to have a canvas. So canvas. Now let's view. So I'm a C++ main. In terms of Python, I only really looked at its syntax sheet on how to do the classes, and then understanding how like its interpreter and some lower level stuff. I can be aware that, for example, certain variables are passed by value, other are passed by reference. And then also, fun fact is that pass by reference is kind of just cleaner syntax for pass by address. You might have like a big debate on that, but if you're looking at C++, C, and how the compiler works and how assembly works, there's not really a difference between passing by reference and passing by address. It's just that passing by reference looks a lot cleaner. Okay. Now, there might be some advances in like assembly that I don't know, but when I was reading on like compiling theory, what happens to the code, especially in assembly when you're like doing individual pointers to like the address, and then I was looking up like, so how do they do reference, and a lot of people said that, but who knows, there might be you know, stuff that's changed in a while. Let's see. So tk.resizable blah 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 attribute. So this one is just a robot class. I don't know what just happened there. And so it's kind of, so I want this thing here, and then Python tk enter download tk enter docs. So tk, when I was looking at the documentation, it gave me a link to the C++ version, and as much as I love C++, I'm trying to find out how to do this in Python. So that was a very interesting experience last night. So tk intern API. So tk enter modules, let's try that. So canvas. So this is for tk online, Tinker supported by fbot. Let's try that. So canvas. So move to modify the items. So concepts, arc, bitmap, window. So canvas.item equals canvas.create line. Item config. So canvas contains items, but then like you can store the items like that. So I'm guessing that's how you modify the item. So I could probably stretch it to like 27, because I honestly kind of not in the mood for math. The breakout sessions in my math class also use Python, but it's like stuff that's like meh. They're kind of just using Python as like some advanced calculator, you know. Because if you put in Python, you know, 5 plus 5 in its console will give you the answer, and if you use like certain libraries, it's basically like a TI and Spire. So this is draw, canvas equals canvas, self canvas color, self.canvas.move, self.id, self.canvas.move, position, self.canvas.chord. So let's see. So self.canvas equals to that. So canvas.creative rectangle. So there we go. So self.id is how I'll move it. Self.x, but it's always at 0. So since it's always positioned at 0, there's no need to change it there. So you just put a constant there. Okay, so canvas. Do I even have to put like canvas equals none? So I'm guessing if I want a default thing in Python, I would put it like this. But I'm guessing a lot of like of classes properties are implied by its initialization function. So I guess one in Rome, act like in Rome. So I'm gonna yeet the graphics proxy. So I'm gonna self, position, size, and we're just gonna make it blue, cause Mr. Blue Skies. Da da da. Let's see. Size is blah blah blah. So, I'll just do that, and then canvas, and then we have this generic input code where you just basically go self.canvas equals canvas, self dot is it position equals position, self dot size equals size, and so on. I probably should move that down. P. Yeah. Some of you are maybe. I feel like some of you might like be tripping on like kind of like me using the command line as a programming environment, but I've been able to use it for first robotics competition, which is like this international thingy competition, but it's like you have like really advanced stuff. Especially I like FRC compared to Vex because you're able to do more. You work with like an 80-pound piece of metal, and it has pneumatics and stuff. Like here to give you guys an idea of what FRC is, and this is like high school students. So like these robots, you're actually using not international, like you're using like certain like manufacturers will actually provide some annoying music like that. These are very big. You can see already the scale with the people. Like the robot before last year on the team I've worked with was 6466, but their robot had a pincer, and if you weren't careful, since it was hooked up to pneumatics, you could have honestly like actually pierced someone's calves and, you know, drag them to hell or something. So that's pretty nice. Like you're working with like an actual robot instead of like plasticky toy thingies. Not that there's anything wrong with like using Vex. Like, you know, it's a very good, like, you know, being able to make cool stuff, that's cool, but like there's just something with working with metal and like larger robots. So it is 10:29. I gotta head to class. At least we've figured out how to, you know, at least a general idea of the syntax. So yeah, it might, like, sometimes you're just analyzing documentation, you're still being productive. So even if you haven't written many lines of code, you know, if you want to just add to productive, we made a new Git branch, we added a Git commit, so there's there. But have a nice day. I might put like another live stream later. This was kind of like time pressed because I had to recompile my encoder. But anyways, have a nice day and see you guys.